Okay, so this video is about creating a graph for the length versus time squared for the falling card through the PhotoGate. So we need to do one more step before we can import the data to Logger Pro. So we're going to copy this heading and put it next to our second table, and also use the data of this column by typing the equal sign, data from this column, enter, and we pull this down. Okay, so now we have, for table number 2, we have the time squared, the card length, and the uncertainty on the time squared. And now we have to copy this data, so we're going to copy this data and paste it on Logger Pro. So I asked everyone to download Logger Pro, so you have to paste that information onto Logger Pro. Obviously the first line has to be deleted, and okay. So we're going to use Logger Pro to do our graphing. Okay, so the column, they have to be renamed to be properly evaluated. So you're going to click twice on the first column, and it's time squared. So we're going to click here, superscript 2, so time squared. The short name is going to be t squared. So again, you type t, superscript squared, and the unit obviously is going to be second squared by clicking here, superscript squared. We need to adjust the number of decimal places. We have 4 decimal places. You want to keep that constant. And also we have error bars on t squared. So we're going to use the last column that we have calculated. And for this, you're going to click error bar. And instead of giving a fixed value, you're going to say use column. And which column? The last column that says in blue. And done. Okay. So now time square is set. So we need to repeat for the second one. So length. So the decimal places, we have 2 decimal places. The error bar is a fixed value of 0.001. And the name is card length. The short name is going to be L. And the unit is going to be meters. And you can press done. Okay. So now obviously the point, we can see them, they're really in that any area. So we need to click on auto scale to see the whole range of data. Okay. So we see the error bars. We see that the error bars are different for each data point, which is what we have calculated. And we can put a best fit line by clicking here. So we know the relationship is a linear graph, and we have a best fit line. And according to the experiment, the gradient of that best fit line is half gravity. So if we look closer, and if you look closer here, we can see that the slope is 6.342. Okay, so the next step is going to be to do the extreme slopes, because the extreme slopes are going to allow us to find the uncertainty on gravity. Okay, so to summarize, now we have graphed the card length versus time squared. We have the equation of the straight line, and we can read the gradient from that box. Obviously, this is good to get the gradient, but we need to find the uncertainty of this measurement. And then for this, we're going to click on this button here. It says curve fit. And we know it's a straight line, so it's going to be in the format of mx plus b. And we're going to try fit. So it's going to create an additional line exactly on the other that we've previously made. But this time we're going to click on manual and press OK. So we get this new line here, and we want to be able to move that line. Right click the line, line of best fit option, and then you click enable drag line and press OK. So when you do that, you're going to see those little squares here and there, and when you move over those little squares, you have these two arrows, and you see that you can move the line. So I can move the line all the way down to the error bar at the top and all the way up to the error bar at the bottom, and this is going to give me the smallest gradient. And once this is set, I click twice here, I disenable the enable drag line and click OK. So now we need to have the other extreme slope. So I'm going to move this box over here because it's connected to this slope, and this box over here because it's connected to this line. So we're going to repeat the process for the highest gradient. So again, try fit, we move back to manual, press OK. So this is my new line, and if we click twice, enable drag line, OK, and you can move the line all the way to the highest possibility in this direction and then here. So now again click twice and lock the line by pressing on the enable line drag, and we're done. So now we have the three lines: the extreme slope, the gradient, and the maximum gradient, the minimum gradient. So we can find the value of gravity, the value of the maximum gravity, and the value of the minimum gravity. And from this, you can calculate the uncertainty on gravity by doing delta G is G max minus G min over 2. To make this a little bit more visually friendly, we can change a few things. So in the line of best fit option, you can change the appearance. So we can change the number of decimal places, so maybe 3 decimals is enough. And then the appearance, we can, since it's the highest one, maybe we can put it in red. And then maybe we can make this more visible by increasing the font size to 14. Press OK, and you see this is for the highest slope. What is this graph missing? There's one last step for this graph, and the last step is going to be to add the title. So if you move your mouse anywhere above the graph, but still in that box, if you click twice, it will give you graph options. So graph options and then title, and you type the title: graph number 1, card length versus time squared. And we're done. That's it. Your graph is ready to be copied and pasted anywhere you want. You can copy and paste it in a Word document, or you can print it, and that's about it. Thank you for your attention.